Good morning, good evening, or good afternoon, or wherever you are, good night, whatever time zone it is. I hope you're having a good time. So, where are we? What are we doing? And we are still doing what we were up to, where we're going to link, um, we're going to take the mermaid diagrams for TBDEX and for DFFML, and we're going to mesh them. And then that's going to show us, that's going to hopefully guide us a little more as we go about our journey here. So, or our adventure, as it were, or Alice's adventure, eventually. All right. So once we get this done, what are we going to do? So why is this important? This is going to be the first. What we're doing here is the first link in Alice's memory, right? So if we can put a program execution flow and trade the program execution flow with ourselves, uh, we form a record of past executions, because the first execution will suggest the execution of the next execution and so on and so forth, via the strategic plans. So, and effectively what we're showing here is how Alice could do them in house, or she could outsource the execution of Bob, and her prioritizer is going to make that call. And Bob's prioritizer is going to make the call whether he wants to schedule or not. And they're going to communicate via TBDEX. All right, let's get going. Okay, so where were we? Well, let's forget about where we were and approach this with fresh eyes. So this looks like a giant fucking mess. So what are we doing here? Run system context, operation, get bids. All right, I think that we were in the middle of reworking this because we had tried it like two or three ways now. Yeah, so execute on pro. Okay. Let's just look at the fuck that thing. Let's look at here. This is the truth. Da, 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 da. Execute. Okay. Get bids on system context execution. All right. So I think this is too complicated. So let's throw Alice's prioritizer into here. See what this looks like. All right. So the prioritizer will decide whether we want to do this in-house or not. All right. So let's see. And then Alice will bid on this herself. So if we don't want to get bids, we'll fall through. Um, but you can also have a situation where Alice, maybe has some, uh, will bid for her own job, because that way the goal is to always have the same flow, right? So if we see a new bid come in and we're Alice or we're Bob, we're going to bid on it the same way either way, right? So we might take in to the prioritization information for our bidding the fact that we're bidding on our own job, right? And so, the price will be, there's no price, right? The it's just, it is what it is. We're going to communicate the fact that, hey, it may cost this much for us to run it in house, um, but you're not going to pay any extra. So here's sort of we can declare all of this within the DID that gets set for bid. Basically, what are the side effects that you're going to experience by going with this bid, right? And that's the contract, that's the manifest, that's the DID method. That's the thing we're trading over TBDEX. Okay, so get bids. Prioritizer, get bids. All right. All right, so is this totally fucked now? What happened? Oh, we're probably trying to route prioritizer somewhere. Yeah, we got to do a mermaid to prioritizer. It's always an exercise in naming. All right, prioritization. So if Alice decides, so execute system. So Alice in-house node is has the label execute system context. Uh, uh, in-house. In-house, maybe not the best word. So execute system context. Alice execute system context. Get bids on system context execution. We'll say Alice execute. We'll call this node Alice execute system context labeled node. We will call the node itself Alice. Combined Alice and execute. Okay, execute Alice, execute system context self. Okay, yeah, we'll just say prioritization. Okay, so and then we'll funnel prioritization. We'll funnel prioritization. We'll go to both of these, right? All right, we're going to swap prioritizer and prioritization. See what happens here. Okay, so we go from the lock network, we begin prioritization, we hit the prioritizer. We have, okay, so execute system context itself. Run an operation using. Maybe we need to put this after. All right, Alice opamp CTX run operation. This thing is like a final thing. This is like, if we actually end up running it. Execute on prioritizer, go ahead. Okay, yeah, so this is prioritization. So when we get out of here, then we might execute. So prioritization. So whatever the last thing is, execute on prioritization. Go ahead. Okay. So get bids. So this would be execute system. We need one that says, new system context. Okay. Okay, so there's a new system context, right? So this is when we have, yeah, so this is, our input set context or our input, yeah, our input set, which has an input set context, right? And so, a new one of these comes in, we're being asked to execute it, right? It hit, we went through the lock network and we're going to execute now. So we may, um, let's see. New system context executed in-house. New system context. So Alice Prioritizer goes to execute system context and the message on what it's saying while it's going there is new system context executed in-house. New system context, explore uh, outsourcing opportunities. All right. And then in that case, she will go get bids. All right. Well, and how will she get bids? Well, she will broadcast the system context, system context, or let's see. All right. So now when we say on chain, really what we're talking about is just sending this DID blob somewhere that someone else can get to it, whoever the intended recipient is, right? So that's sort of the beauty about this. That's the real beauty about this DID stuff, this distributed web node. All of this is like chain is it's not like the previous blockchain stuff so much, right? It's more of like a distributed messaging system. I mean, it's really just a secure messaging interface. Um, it happens to be that the messages are, when you send one message, it links to the previous messages, right? Or whatever previous messages you wanted. It's just that's the chain, right? So it's not like, I mean, it's a linked list, right? It's a cryptographically secured linked list. And that's how Bob's going to know it's really coming from Alice and that Bob is actually going to offer to execute this thing. And it's not just coming from someone random, because why the hell would Bob do that, right? You know, he's not just going to go execute random people's code on his computer unless he knows exactly what he's being asked to execute and who is asking him to execute it. And you know, what assurances does he have that this is not going to hose his whole setup, right? Or cost him a lot of money, right? So he thinks that he can do this for Alice. Um, right? Maybe Bob's got some server that's just sitting idle, right? Um, or you know, yeah. So, and you know, he'd like to be able to, for example, this machine right now that we're on. Um, this is not taking a lot of look. Let's like really 100% CPU. Okay, whatever. Um, Wait, I disproved my point, computer. Well, now it's 15%. So, you know, we have a whole, whatever 100 minus 16 is, 84% CPU that could be doing things, right? And I'm sure there's a lot of other computers on the network. Um, well, hopefully they're not doing a lot of things. But, you know, there's probably a lot of other computers that could use some compute, you know, because they are at 100%. And you know, it would just be nice if it was a reasonable request, we could just do it for them. You know, there's really no reason to have all these computers on and not doing anything. They're sucking up power anyways. So it's just like a distributed backend. So basically, um, how do I get off track? How do I get off track? Okay, so new system context, explore outsourcing opportunities. Alice get bids. And then, so then she should ensure, so basically if she's going to get bids, she's going to need to Alice get bids. If you give, okay, so ensure system context on chain and clearly uh, broadcasted um, request for bids to chain. Too many R's there. All right, so we're going to send that stuff to the chain. Get bids on system context execution. Ensure system context on chain and clearly broadcast request for bids to chain. Okay. So then, you know, that goes to send DID doc to chain. And this is going to, this Web3 we'll want to put at the top here, then it looks like. So we're going to put this on top of TBDEX. Or maybe we'll put this below TBDEX. So that way the thing that we're copying from an upstream is, and actually we should, oh, there's no comments in Mermaid, but we need to remember, well, we have the video, that we source this from TBDEX, and I think we have the links too, so. Wow. Okay, so this all needs to go. Yeah, you really got to define all the things and then link them at the bottom. we go. Get bids on system context execution. Boom. Send the ID doc to chain. Boom. Over to new inputs. Boom. Down to Bob. All right. So we may need another. So Bob may just see this system context fly onto the chain and go ahead and bid on it, right? But we may want to have. He may do that, right? So he may do that. Yeah, he may do that. So he might just do that, right? We're just gonna assume maybe, yeah, we're gonna leave that there. Um, so the moment this system context gets suggested by a strategic plan, it should, get added as input. The input network should transparently add it to the chain, and Bob should pick it up just as Alice did, right? And it should go for prioritization, right? So in the same moment that Alice is seeing it, right? Well, about the same moment, right? We could make it. We can gate it with async IO. This will be fun. So we can. This is async IO is great for this. We can have async IO events. This is just fantastic. Okay, we can run it all in the same thread. No multi-threading. Thank God. Okay. You can spin things out to threads if you want, but all of this is IO, which is why this is so great. And then you can spin out CPU bound or GPU bound to threads, and we'll be able to do that automatically. So that'll be sweet, and we'll be able to assess locality so that we can optimize for what is in CPU bound threads and what's in. We can throw whole subsections of data flows in CPU bound threads. Because we understand the locality of their inputs. And we're collecting data on their runs, and we can optimize and then pick out what subflows, what things should be subflows in what orchestrators. It's going to be sweet. And Alice is going to do it all for us after we build up, slowly over time. We're going to build up those capabilities. So something's mad. Okay, there we go. Okay, so get bids on system context execution. Boom, comes over here. All right, Bob. Here's Bob. Get bids on system context execution. All right, let's go over to Bob's world. Bob, the Ask Builder. All right, Bob, the Ask Builder is going to build an ask. And he's going to do that. And he's going to heavily leverage find and replace. Oh, wait, no, that's me. Okay. We didn't get all of Alice's name. We missed the... All right, there we go. Bob. All right. Boom. Watch that. Boom. Bob. Boom. This is ridiculous. Okay. Wow, Bob. A lot of stuff here. Okay, so get bids. Okay, so get bids. Okay, so now let's see. So Bob prioritizer, new system context executed in-house. Bob execute system context. New system context executed in-house. Okay, so Bob's gonna have a new system context from external um, uh, place bid. Here we go. All right, okay. Place bid. All right, Bob's going to generate an ask. All right, let's get rid of that other shit we had with the ask. Let's see how this looks. Wah! Okay. Why is there another thing going from ask? Okay, so ask. All right, we're getting rid of all things that are. Okay, here's the ask. All right, new system context from external place bid, and then ask. Okay, so that's Bob. Bob makes the ask, conditional offer. That's Alice. Alice makes the conditional offer. We're gonna delete this all this so that we only have we're gonna simplify Bob's side here. Okay, so wait, where's that blob here? Okay, there we go. Oh wait, this goes here. Okay, so this ask, these are also happening. So all this TBDEX stuff is also happening on a chain of DIDs. Okay, so yeah, so we're gonna run. So we're gonna generate TBDEX messages, and we're going to they're going to be themselves within DIDs. So yeah, so when we talk about creating all this stuff, we're just going to create an input object, and that input object is going to be um, added to the send DID doc to chain. Okay, so maybe there's a better way to say this. All right, TBDEX messages. TBDEX message. All, or let's see, let's just say TBDEX, all messages communicated via chain. We're just doing this for simplicity right now. We're just sending, I'm well aware that this is terrible performance-wise, but for the simplicity's sake of using a single transport mechanism for our POC here, we're just going to send everything to the chain, right? That way, we serialize to a flat file, we pick up another machine, all as well. So tbdex, all tb. I'm putting it in the diagram. So messages communicated via chain for POC. Okay, all tbdex messages communicated via chain for POC. Okay, great. So all tbdex messages communicated via chain for POC. What does this end up looking like? All right, let's see. This is gonna be a fucking mess. Oh God! All tbdex messages. Yeah, that's disgusting. Maybe we should just put this as a little. Make ourselves a little notes section here. It would be really great if we could just define architectures using mermaid diagrams. Okay, so notes. All tbdex messages. Okay, notes. All tbdex messages communicated via chain for POC. Yeah, okay, so let's just do that. That'll be. I think that'll at least save it in our, save it in memory here, so it doesn't get lost. Okay. Um, let's see. Wow, really hard to see. I can't read any of this. Yeah, okay, I can. Okay. All right, let's go back to Bob. So Bob, let's say you found a new system context and it came from an external place, external entity. Create offer, aka bid on job. Respond with proposed DID of executed system context given as source currency. All right, so what is Bob going to need to do for that? Well, he's going to have to create a DID, right? So he'll have to take the system context, now build a new system context using his top level system context, right? And if he can do that, uh, if he can generate a valid system context, um, like, hey, this thing requires VMs, right? Well, does Bob have this thing's gonna we're asking you to spin up 3 VMs and give us SSH access to all of them, right? So, uh, do you have access to something that will let you spin up VMs, Bob? Okay, well, you don't. All right, well, that's going to be a problem, right? So you can't generate a valid system context, therefore you can't generate a bid. You could, but Alice is going to validate your bid, right? And she's going to say, well, this is not a valid system context, right? And how do you tell that? Well, you look at all the inputs and make sure all the inputs map to somewhere within the architecture, right? Or so, um, so yeah, so basically, Bob should determine the validity, his ability to generate a valid. We should probably write this down. So, determine ability to create valid system context using given top level system context and assets at disposal, right? So if he doesn't have some asset at his disposal, which this thing requires, then he's SOL. He can't bid. And then he's going to go ahead and post a ask message, with this new DID that he's created with the proposed system context, which basically this is going to have all the more specifics on, hey, this is what I'm saying is an equivalent system context. This is what Bob's saying is basically, hey, here's the best I can do, right? And then Alice will get this bid, right? And she's gonna take a look at it, and she's gonna so where is she? Explore outside. So get bids, right? So ensure context on chain, input to chain. So right now, so new system context executed in-house. So now we have what we're going to see. This is in operation, right? So this is in operation, executing. So let's see. So Alice says get bids, and then she fire and forgets, or well, she doesn't forget. She needs to set some kind of wake up. So she'll wake up. So let's see. Alice, check on bids. Right, so she's going to wake up and she's going to periodically she's going to check on bids, right? So if a new bid comes in, right? So prioritizer, system context, bid received, right? So she'll check on bids, and then maybe there's also like timeout, right? So system context bid received, prioritize timeout for bid system context bid selection. right? So basically, hey, she'll have some, and this goes into like, how long does she have to think about it, right? And this is where we're kind of changing the way we think about how do we program, at least Alice, right? Is it doesn't have to get done immediately. Take your time, find the best solution for the job, and then get back to us when you figured it out, right? Don't just basically no more like well, we'll have static decision trees obviously, but basically we're going to assess our options first, right? We're going to build all the static decision trees that are available to us, and then we're going to whittle down our choices, and really assess our options, and then we're going to execute that, right? So then that's basically our timeout, right? Or we're basically going to see this bid come in, and we're going to say, hey, looks great, let's just go for it, right? Okay, so other Alice in-house on a different machine says she can execute it for no cost, right? On a machine that's already running. Basically, this is a no cost thing to run this on this one computer within Alice's internal asset pool. So then she would just, if she saw that bid come in, she would just accept it, maybe, right? We might have a strategic plan that would, or we might have let's see. So that's going to go into, let's see. She would, let's see, offer, accept. So she's going to go in and IDV request. I don't know what IDV request is. What does that mean? Let's update our diagram. All right, looking much better here. Okay. All right, I'm going to take a break.